Hello, I welcome you all for my mathematics class. Today, let me teach you how to solve a heat equation. You see that it is given in the problem. There is a rod lying like this. I take this point as O and this as A, and this is 30 centimeters. There is a rod which is of length 30 centimeters, and it is the two ends are kept at 20 degrees centigrade and 80 degrees centigrade. Here it is 20 degrees centigrade and here it is 80 degrees centigrade. Now it is left as such and allowed to attain a steady state. A steady state in the sense that the function distribution, the heat distribution function, namely your u of xt, will be independent of time in the sense that the derivative of u with respect to t will be 0. So this is, I'll write equation afterwards. Now you see that I'm just explaining the gist of this problem. So after then what happens is the two ends are brought to 0 degree centigrade. Now you are asked to find, or rather we are asked to find, what is the resulting temperature function u of xt in the rod. Are you able to understand? I'll repeat this. There is a rod which is kept at, the two ends are kept at 20 and 80 degrees centigrade respectively. It is of length 30 centimeters, and that it is allowed to attain a steady state. After then the two ends are subjected to 0 degree centigrade. Now we are asked to find what is the resulting temperature function, namely u of xt. The temperature function is the u of xt in the rod. Now say the procedure is the same as the vibration of a string. You see that first you write the differential. See the differential equation. This is a partial differential equation of heat equation. This is nothing but the heat equation. The heat equation, the heat differential equation is given by, see, is given by dou u by dou t is equal to alpha squared into dou squared u by dou x squared, and u of xt is a function. It is called your temperature function or distribution function, or otherwise call it as a heat distribution function u of xt, and this depends on x and t, where x is the it depends on x is the x or points on the rod, and t is the time. And you see that this is what we are going to find. This is what we are going to find when the two ends are subjected to 0 degrees after the rod attains a steady state. Okay. Initially it was subjected, two ends were subjected to 20 degrees centigrade and 80 degrees centigrade. Now you see that it is given. Now since see at first one, see I write here, see u at 0 at time t is equal to, you are given that it is 20, and u at 30 at time t is equal to your 80. Now it attains steady state. Therefore dou u by the derivative with respect to t is 0. This implies dou squared u by dou x squared is equal to 0. Here you see that your alpha squared is equal to K by rho C, where K is the thermal conductivity of the material, rho is the density of the material, and C is the specific heat of the material. So this only implies this is nothing but the second order differential equation. You will find that this dou U by dou X is equal to C1, which implies U is equal to C1x plus C2. So we have got this U when it attains a steady state. That means U of x at time 0 is equal to, you get this to be C1 at time t is equal to 0, steady state, C1x plus C2. Now U of at 0, see when it is when x is equal to 0. So when x is equal to 0, U of 0 is 20. So you see that this will be 20 is equal to C1 is 0, so this is 0, C2, so this implies C2 is equal to 20. Therefore your U is equal to it is C1x plus 20. Now U at the other end, what is that? U at when it attains a steady state, you see that when it is 20, see it is 30 at time t, at time U of 30 is equal to, it is given to be your 80. Therefore 80 is equal to C1x plus 20. This implies your C1 it is 80. Therefore you will get this to be C1x is equal to 60, but C1 is equal to 30. Here you see that C1x, here you see that 80 is equal to C1 into 30 plus 20. This implies C1 into 30 is equal to 60, or C1 is equal to 2. Therefore U of x0 at steady state is 2x plus 20. So you see that when it attains a steady state, you get U of the temperature function is U of x0 is equal to 2x plus 20. So you see that you get U of x0 is equal to 2x plus 20. So this is what I have. Now after it attains a steady state, the two ends are subjected to 0 degree centigrade. Now we have to find what is the value of U of xt in the course of time. Okay, now what happens here? So now I'll write here, now the new boundary conditions. See, now the boundary conditions are, see, U at, what is that? It is U at 0. This point is taken as the initial point 0 at t is equal to 0, and U at the other end 0t also equal to 0, and your U of x0 at time t 0 is equal to 2x plus 20. So these are the new boundary conditions we have got here. Now we have to get the value of U of xt. Now U of xt is given by U of xt is equal to the, see, this is equal to a cos px plus b sin px into e to the power of minus alpha squared p squared t, the most suitable solution to 1. This is the 1. This is the most suitable solution to 1. This is the most suitable solution to 1. Now we have to find the values of A, B and P. Because if I can find the value of A, B and P, my problem is over. Now by applying, I write here, find A, B and P by applying boundary conditions. Now let us start applying this. So one is u of 0t is equal to 0. This implies 0 is equal to, put x is equal to 0, it is 1, and this is 0 into e to the power of minus alpha squared p squared t, and this is not equal to 0. So this implies a is equal to 0 as e to the power of alpha squared p squared t is not equal to 0 for t greater than 0. So we have got a is equal to 0. Now u of xt is equal to b sine px into e to the power of minus alpha squared p squared t. Now apply the second boundary condition. It is 30t is equal to b sine 30p into e to the power of minus alpha squared p squared t is equal to 0. Now this implies sine 30p is equal to 0 as b is not equal to 0, and already this is not equal to 0. E to the power minus alpha squared p squared t is not equal to 0 for t greater than 0. For t even for greater than 0, you see that this is not equal to 0. B cannot be equal to 0 because if you put b is equal to 0, a is 0, b is equal to 0 means there won't be solution. So you see that this will not be the solution. So you see that sine 30p is equal to 0. So this implies 30p is equal to n pi. Therefore p is equal to n pi by 30. So I have got the value of p to be what? P is equal to n pi by 30. So but I will keep this p as it is till I will apply the value when it is required. Till then you understand that this p squared is p is nothing but n pi by 30. Now let me apply the third boundary condition. Now apply the third. Now what is that you are having now? U of xt is equal to, you are having it as b sine px into e to the power of minus alpha squared p squared into t. Now you apply this, p value is known. See, p is equal to what? N pi by 30. So we have got this. Now what is your u of x0? U of x0, put t is equal to 0. So this is sine px into e to the power of 0 is 1. So this is equal to sine n, I will write here, n pi x by L by 30, and n takes the value 1, 2, 3 like this, because this value is not for one point, it is for numerous points lying on the rod. So you see that u of x0 is equal to b sine in, so for some point x, this will be the solution. For some point n, say for n is equal to 1, n is equal to 2, n is equal to 3, you have got numerous points on this, that in general, so this is maybe for one point, for in general, for various points like this, we will have in general, see, in general, this u of x0 will be equal to, it is 1 to infinity of, it is b sine n pi x by 30. And but this is given to be equal to what? This is your 2x plus 20. So this function is given to be 2x plus 20, and therefore what is that you get here now? So this is 2x plus 20. I have put here 1 to infinity because this is for, there are numerous points like this. At u of x is equal to 0, for numerous points this b sin n pi x by 30 is equal to 30, and therefore in general u of x0 will be equal to what? 1 to infinity of b sin n pi x by 30, which is equal to 2x by 20, and therefore see this bn, I will write this here, I will take it as bn, and you see that this resembles a half range Fourier series. So bn is equal to, its value is given by, see, it is given by 1 by, it is like this, see, 1 by 30 by 2, then integral of 0 to 30, it is 2x plus 20 f of x into n sin pi x, n sin n pi x. See, it is n sin n pi x, sin, it is sin n pi x, sin n pi x, sin n pi x by 30 into dx. Now you see that we can use Bernoulli's method of doing it. So 1 by this one. So you see that this is 2x plus 20 into minus cos n pi x by 30 into 30 by n pi. Then it is minus, differentiation of this is 2x 2 into, it is minus sine, this is cos, minus sine n pi x by 30 into 900 by n squared pi squared, keep this in a bracket, and this is 0 to 30. So what is that you will get here? So this is equal to 1 by 15. Now if you put 30, this is 2 into 30 is 60, it is 80. Into, if you put 30, it is minus cos n pi into 30 divided by n pi. Keep this in the bracket. Minus. So this will become plus. Minus into minus will become plus. If you put 30, 30 and 30 will go off, giving you sin n pi. Sin n pi is always equal to 0. So this is 0. Then minus, put x is equal to 0. So if you put x is equal to 0, it is 20. Minus, if you put x is equal to 1, cos 0 is 1, minus 1 into 30 by n pi. Keep this in the bracket. Minus, it is plus, okay, plus. Then sin 0 is 0. So don't worry about this, you will get it as 0. So you are left with 1 by 15, and this is minus 2400 divided by n pi into cos n pi. Minus into minus will make it as plus. It is 600 by n pi. So this is what you will get. So what is that you will get here now? Simplify that. So this one bn is equal to 1 by 15. Take this 600 by n pi out. Inside the bracket 1 minus 4 cos n pi. So what is your bn value? So this is equal to 40 divided by n pi into 1 minus 40 into minus 1 to the power of n. Minus 1 to the power of n because cos n pi. Cos n pi is alternately, if you give 1 it is minus 1. If you give 2 it is plus 1. So like that it takes the value 1 like that. So what is that value that now you get? So you have found the value of Bn. So you are able to get the value of another constant, namely Bn is equal to 40 by n pi into 1 minus 40 into minus 1 to the power of n. Now, and therefore here it is, yes, you can take that. So you can write the therefore your u of xt will be equal to sigma of 1 to infinity. It is 40 by n pi into 1 minus 40 minus 1 to the power of n into sine n pi x by 30 into e to the power of minus alpha squared n squared pi squared by 900 into t. So what is that you will get here? So the answer is, so this is equal to, take this 40 by pi outside, within brackets 1 to infinity of 1 by n into 1 minus 40 minus 1 to the power of n into sine n pi x by 30 into e to the power of minus alpha squared n squared pi squared t whole divided by 900. So this is my answer for the problem. So this is how we do, but I tell you that it is very, very important to understand and know how this differential equation for this comes and how we are able to arrive at the solution to the problem. There will be 3 solutions as I discussed while doing the vibration of a string problem, that is wave equation problem. So I will teach you how to arrive at the differential equation, differential wave equation for the string problem, that is the wave equation, and also for the heat equation, and I will discuss in length about the solution to the problem and why we should prefer a particular solution. These things will be taught in the coming classes. So with this I complete this problem. I will do more problems in the heat equation after 2 or 3 classes. Okay, thank you.